Good morning and a hearty welcome to all the participants for the fourth day of the faculty development program on artificial intelligence and machine learning for mechanical engineers, which is conducted in association with the IEDC cell of the NMIT. I also welcome Dr. Vijayashri, the head of IEDC cell BNMIT, to the session. Dear participants, we will be starting in 5 minutes time. We are waiting for the speaker to join in. After he joins, we will be starting the session. Please be online.
Good morning, Narendra sir. Karthik sir, the speaker has joined.
Yes, sir. Yes, sir. I'll be starting the session. I welcome Mr. T. Narendra Reddy, the resource person for this session. I'll be starting with a very short bio of the speaker. Mr. T. Narendra Reddy is a scientist at the Center for Smart Manufacturing and Precision Machine Tools of Central Manufacturing Technology Institute, that is CMTI, Bangalore. He is specialized in the areas of system, machine, and solution development related to smart manufacturing and Industry 4.0, ultra precision machines and subsystem development, nanotechnology equipment, development of statistical techniques or algorithms for error compensation, software development for precision machine tools, motion controller for nano product development, artificial intelligence and machine learning based algorithms, and their development for real-time machine error corrections of ultra precision machines. Sir has contributed for indigenous product development and, to name a few, development of intelligent ultra precision turning machines, development of ultra stiff ultra precision turning machines, development of portable scanning tunneling microscopes, development of closed loop nano positioning stages, and development of nano motion systems, which has hydrostatic slides and aerostatic spindles. He also has numerous journal and conference publications to his credit and is a life member of Metrology Society of India. He is also an active member for the Career Enlightenment Program and Design Innovation Clinic, abbreviated as DIC, to help engineering students. And he is also a course coordinator and faculty member for training programs on smart manufacturing and Industry 4.0, which he conducts regularly for academic and industry participants. It is our immense pleasure on behalf of the Department of Mechanical Engineering, IEDC cell, and also management of BNMIT, I extend a warm welcome to Mr. Narendra Reddy, and I request sir to please take over the session and start with his presentation. Thank you. Sir, you can share the screen and sir, can you share the screen, sir? Is there any issue?
I think Karthik sir.
Yes, sir, please.
Sir is on the line or whether.
He is in the meeting, sir. He is in
Okay.
the meeting.
Hemant sir.
Yeah. Now I am good.
Yeah, you're audible, sir. Sir, very good morning.
Very good morning, sir. There is some issue.
Welcome to our Bainam family, sir.
Yeah. I could able to hear the introduction. I'll proceed with my presentation now.
Yeah, sir. Please, over to you, sir. Please.
Yeah, is my voice is clear? Because
Yeah, absolutely clear, sir.
then no issues. Good morning, everyone. I'll be sharing my presentation now. Is my screen visible now?
Yes, sir. Please proceed,
Yes,
sir.
sir. It is visible.
Yes.
It is visible, sir.
Good morning, all the participants, for the talk on machine-to-machine connectivity and its applications in metal cutting. Myself, Narendra, working as scientist in Smart Manufacturing Department at CMTI. These are my contents of the presentation. I'll be talking about what we are doing in smart manufacturing at CMTI, because I see a lot of academic participants here, faculties. They can understand what we are doing, and we can also collaborate and work together. And there are some scopes and opportunities where we can collaborate and do some developmental activities in this area. And as the topic is on machine-to-machine connectivity, I just want to brief where this machine-to-machine connectivity is connected to the smart manufacturing technologies. And of course, the topic is machine-to-machine connectivity. I'll be giving a small introduction about what is machine-to-machine connectivity and what are the applications of machine connectivity, mainly in metal cutting applications. And then today, I think if you look at India, there are a lot of industries where they have older machines. For those machines, or legendary machines they call it as, how to convert those legendary machines or legacy machines to smart. That is one of the major challenge for our country, because we cannot buy the modern machines and make a modern factory because of investments. And of course, in academic institutes also, you will be having some conventional machines. That's why I added one more topic: how to convert these legacy machines into smart. I'll be little touching upon that. And then, and when you talk about smart manufacturing or IoT based measurements, this condition monitoring is one of the important area. There I'll be touching about introduction to IoT on vibration measurements. And then, as in the introduction it has been mentioned, I have involved in development of intelligent ultra precision turning machine. We developed this machine in year 2013, where we have used a lot of AI and ML techniques. I will be sharing some of those results, how we could implement and got benefit from those techniques. That will give more insights, because that is, that work was the first time in the country where people adopted AI and ML techniques for high-end machines. With that, I'll be starting my presentation. as I said, we have a center called as Smart Manufacturing Demonstration and Development Cell at CMTI. It is a part of Department of Heavy Industry. What we do in this center, we have basically we are working on 6 activities. One is implementing. Just a moment, there is some noise. I will close the door. Yeah, we are working basically on 6 activities. One is on Industry 4.0 implementations at CMTA laboratories. And the second one is we are working with industry collaborative projects. That is where we need to work on development of products which is required for the industries. There we have 6 industry partners for our project. And then to give awareness and demonstration to MSME and even to academic institutes, we are establishing one workable smart factory at CMTA. Hopefully by 2022, you will be seeing this factory. And as I mentioned, it is a part of a Department of Heavy Industry Initiative, Samarth Udyog 4.0. We are part of them. For that, we are getting some funds for training and awareness. In this regard, we are open for collaborative and even for training programs. We are doing extensively training and awareness courses. And of course, for MSME industries, we need to develop some low-cost solutions where we are also working on R&D projects. Okay, this is a small introduction about what activities we are doing at SMDDC. And coming to the industry partners, you can see that we are working on cutting edge technologies in Industry 4.0. These slides I have taken basically to give a feel that what technologies industry wanted. This is a Utunga Technologies. This company, it is a software-based company, but they have a platform called as Javelin. They want to make the Javelin for manufacturing industries. They want to make use of their software for manufacturing industries. For that reason, they collaborated with us, and we are trying to give some algorithms and some some information about what industry wanted. Then we are basically working on machine-to-machine connectivity and IoT-enabled technologies. And with the Acumec, this is a SME basically. They are developing spindles. Okay, whatever you see conventional or even CNC machines, they are selling about 1,000 spindles every year. They want to be global competitive. For that reason, they want to make the spindles into smart spindles. We are basically into this smart integration for the spindle. And then with the Siemens R&D team, we are working on digital twin based availability prediction models for spindle and feed drive system. For those who wants to work on digital twin, what I felt that data is the key. I mean, all these A and ML techniques, they are powerful until unless you have a valid data. Okay, this Siemens project, mainly we are trying to create a test rigs and collect the data and see that how this A and ML modules can be very effective in real time. And then with the HL, we are working on experimental learning in smart manufacturing and industry 4.0. It is purely a CSR activity where we'll be teaching smart manufacturing technologies, where we are establishing hands-on training labs at CMTA, and we'll be offering training programs to engineering students, faculties, students, and even MSME professionals. And then with the Hexagon, we are working on a smart factory and digital twin of a smart factory. And then we have another partner, IMTMA, in Indian Machine Tool Manufacturers Association. They want to give more exposure on this technology to their industries, OEMs and all. For that, they are more connected with the smart factory demonstration. Okay, hope you would have known what and all technologies we are working on. And this is our smart factory. I said that we are going to establish. You can see that the raw material is coming from outside. And once it comes to loading and unloading station, with the help of automated guided vehicle, the component will be going across the factory. And we are using robots for machine tending. And once the machining is done, it will come to measurement station. Once the measurement is done, it will go back to the unloading station. Then from there, it will go to the supplier. This is the complete demonstration. We are going to have it. At the moment, we have 5 machines at CMTI Smart Manufacturing Cell. In fact, I came to Gujarat to buy one of the machines for this factory. Hopefully by 2022 March, we will be able to complete this complete factory. I'll be visiting all of you to come and have a look at it, so that you can see where we can able to collaborate, or you can also learn and implement in your colleges or even industries whom you wanted to associate. Here, the beautiful thing is, you can see here we have some legacy machines in our factory. This is a Shablin 33. This is an old machine, and we are buying our Indian manufacturers' machines, where latest machines like turning machine, VMC, and turn mill celter. And in fact, we are also establishing one sheet metal cutting also. And then we have 3D scanner, then CMM, all this data, because you are not getting from homogeneous machines. There are cross machines. There you need to collect the data from old, new, and then today my talk, if you look at it, I will be showing you how to convert these legacy machines into smart. And I will also tell you these latest machines which you are procured 2005 onwards, they have already inbuilt machine connectivity. I mean, you can able to read the data. Now with that data, you can make your workshop into smart. And then there are a lot of softwares are required. If you want to do complete end-to-end control, if you want, then you require sophisticated softwares. But for academic institutes, I would suggest try exploring low-cost solutions. And today it is very much possible because of openness in technologies, both in electronics and software. And when it comes to Industry 4.0, mostly you are connected mainly at the embedded hardware or at the IT layer, but the requirement will be for the mechanical. But if you can associate with electronics and computer science, you can build beautiful models for this. Now, this is about what we are doing at CMTI on smart manufacturing. Hope you would have got some idea. Okay, otherwise at the end also I am happy to discuss. I will be rushing through because I have 90 slides. What is this Industry 4.0? I think by this time everybody would have known, because the topic itself is A and ML for mechanical engineers, and of course the smart manufacturing is part of it. The only one point I want to highlight here is, as the revolutions are keep coming, only what the difference you are seeing is the level of complexity. Today in Industry 4.0, we are talking about cyber physical systems. We are talking about digital twin. Okay, these are the complex technologies, and it is interdisciplinary. And as I said, my topic is machine-to-machine connectivity. I want to tell you what are the technologies associated with the smart manufacturing, and I will also tell you how it is connected to machine-to-machine connectivity. And every time people say that Industry 4.0 is a technology, Industry 4.0 as such is not a technology. It is associated with multiple technologies. And what are the benefits you get it from Industry 4.0? I think by this time you may be knowing what are the benefits. I will be touching 4 points. One is you can reduce the cost of your whatever part you are producing, and of course the complex parts can be produced, and then you can give complete customer satisfaction, because today servitization is one of the beautiful things. That's why a lot of solutions are coming out. And then competition, you until unless you become a global, if you want to become a competitive, if you can adopt these technologies, you can become a globally competitive industry. And look at Maruti. Okay, by incorporating this Industry 4.0, they can increase the productivity, and they can also improve the quality. And today you are looking at Maruti, they are coming out with multiple varieties of cars. Earlier, go back some 10 to 15 years back, they were having very limited number of product segments. But today, due to this flexibility in their manufacturing operations, okay, all these FMS or even modular systems, robots, those things, they are able to, in the same assembly line, they're able to build multiple product varieties. Okay, and then speed to the market. Okay, earlier days, the design of the car will be released somewhere in 2020, means you will be able to get the product in 2021. But today is not like that. The design, if it is ready, and if if the design is ready within 1 or 2 months, they are able to reach to the market. That is the that kind of support Industry 4.0 can able to give you. And what are these technologies? As I said, smart manufacturing is basically a concept which is associated with multiple technologies. What are those technologies? You can look at this slide. There are 9 technologies which are associated to it. One is autonomous robot. You can look at big data analytics, and then supply chain, because today this supply chain has become very, very important, especially during pandemic time. And additive manufacturing, it is picking up at very faster rate. Maybe next 10 to 15 years, you see a lot of developments, and afterwards you can see a lot of consumable products which can be coming out from this additive manufacturing. Then cloud-based services, I think this we need to thank due to, even though we have a pandemic, due to this cloud services, we are able to communicate and we are able to do our activities smoothly. And in fact, our lecture today is also somehow connected to this. And then cyber security. This is one of the important area where these defense systems are not accepting this Industry 4.0, but people are continuously working. That is how this blockchain and new technologies are coming out. Then industrial Internet of Things. Earlier, I think already IoT is there. Now, industry wanted that devices can be adapted to industrial environments. Their industrial Internet of Things are connected for Industry 4.0. The same things, IoT devices or the sensors like temperature, pressure, whatever you use it for household applications. If you can make them to use it in industry, we call it as industrial Internet of Things. And then horizontal and vertical integration. This is one of the important step in Industry 4.0, without which you cannot able to apply any of this big data analytics or any kind of data taking to the cloud. You need to have horizontal and vertical integration. And then virtual and augmented reality. This is also nicely picking up, mainly for industry requirements. Augmented reality is mainly used for training and maintenance applications. Now, machine-to-machine connectivity is mainly connected to this horizontal and vertical integration. That is what I wanted to convey to you. And now, now the question many times we give a talk to MSME industries, they always tell, sir, how much investment is required? For that investment, when I'll be able to get my return on investments? That is a fundamental question. Every time we get it. For this, the answer for that is this slide I wanted to explain. Industry 4.0, basically it is something like you need to adopt and you need to use it in a very matured way. Then only you can able to see that. That is called as a staged approach. Okay, until unless you follow these 4 steps, we will not be able to see any value for the investments you do related to Industry 4.0. Now, what are these 4 steps? The first step is you need to see. Okay, there was a survey in 2015 by not getting the name, Cisco. Yeah, there was a survey by Cisco. What they said is, in India, 95% of the machines are not connected to each other. That shows that you doesn't know, all are discrete machines. You doesn't know what is happening in the plant floor. Then where is the scope of building AI, ML modules or anything you want to do value addition to that factory? First of all, you need to get the data. That is the first step. Somehow you need to connect those machines and get the data. I think thanks to this machine-to-machine connectivity, last 5 years, we could able to connect 20 to 30% of the machines in our country. Still, there is a lot of scope. Still 70% of the machines are not connected. It means you doesn't know what is happening in those machines until manually somebody has to go inquire from the operator. Otherwise, they don't have any information digitally. Now, thanks to this machine-to-machine communication and these electronics and sensors, we can able to just connect a cable, or you can mount some external sensors and you'll get to know what is happening. That is the first stage. In the second stage, once you know what is happening in the factory, then you need to convert the data. First, you need to convert the data into an information in the first stage. Once the information is there with you, you'll get to know what is happening, and you can also see the factory floor. Then the second step, you need to convert this information into a knowledge. That is where you will be using your AI techniques. Okay, that is where you'll get to know why is it happening. Then you can understand, oh, the data is coming because of these reasons, because you somehow able to convert that information into a knowledge. Now, just knowledge is not sufficient enough. That's why you can see there is no value you are seeing here. Now you need to convert this knowledge into some wisdom. That is where you can able to predict for the future. Suppose if you take a factory like food processing, if one critical machine fails, the entire demand what they are getting, they'll get disrupted. Okay, if you can able to visualize, or if you can able to predict that machine is going to fail next week, then the maintenance engineer can able to take a immediately step for repairing it, so that only for half an hour or 1 hour breakdown he can able to manage his production. That is where you should be prepared for the future. In the third step, you will be converting, again you will be using A and ML techniques. There you can see some better value. Then just by thinking about the future and prepared for the future, it is not okay. You need to take some autonomous decisions. It could be system on its own. It should develop. It should able to take decisions. That is where this industry 4.0 vision is going to accomplish. There you can able to see the real value. Overall, what I want to say is industry 4.0 is basically a journey where that journey has to keep. You need to evolve over the time, and you should build the maturity. Then you can able to see the real value. Okay, that is what I wanted to convey. And there is industry 4.0. If you want to adopt, what I need to do, that is the basic question. Many times people ask this. You need to follow this architecture that is called as RAM 4.0. That is a reference architecture model for industry 4.0. It will tell you all the layers which is required. You should able to connect from physical systems to your business systems. And of course, when you are connecting, it also should have this interoperability. You should have secured protocols. Then you should have connectivity. With all this, both horizontal and vertical integration, you can able to make industry 4.0 complaint factory. Now I'll be getting into machine to machine connectivity and its applications in metal cutting. What is machine to machine connectivity? Machine to machine connectivity refers to networking of machines for the purpose of remote monitoring and control and data exchange. You can use this M2M only on premises or homogeneous machines. You can see in this diagram, the M2M will be always happening with the homogeneous machines, and it is on premises. Suppose if you have a factory in Bangalore, and suppose you take some automobile company like Sansera Engineering, they have 11 plants in Electronic City alone, but each plant are in different locations. But one plant one can able to communicate. Plant one can communicate with all the machines, and plant two maybe he has the robots where they can communicate. But if he has to do remote control or remote monitoring, then you should have some wide way of communication or wireless communication. But still, as M2M uses their own protocols, we are not sure whether it is compatible to these wide or wireless networks. You need to have some gateways so that you can able to smoothly connect all the factory information to remotely. Okay, I hope this picture is clear. Then still I am explaining what is this M2M. M2M, as I said, it is a network of machines which has embedded hardware for sensing, actuation, and communication. And M2M protocol, when we say M2M connectivity, it is basically there are some communication protocols which used in M2M local area networks. What are those communications? Zigbee, Bluetooth, Modbus, powerline communication, low power wireless communication. Then as I mentioned, this they can only, you can take a Bluetooth, very limited distance they can able to communicate. But today we are talking of across the world, we need to access the data, and over the internet you want to take the data. Then you need to have some kind of communication networks. For that, you need to use either wide or wireless networks. Generally, when you take the data to internet, it means it has some IP based networks are available. But M2M, the limitation is it never be IP based. It can be a proprietary also. For that reason, you need to use some M2M gateways. What is this M2M gateway? As I said, that M2M generally uses the protocols like Bluetooth, Zigbee, low power wireless devices, and they will be taking the proprietary protocol or non-IP based protocol, that is a native protocol. With the help of protocol translation, you can able to make it as IP based. Then the IP routing is established. Then you can take across the world. This is the what M2M is doing. And still, what is the difference between, another question many times asked, how then IoT and M2M are different? This slide will talk about it. One is the communication protocols are different. And then in M2M, we are basically talking about machines. When in terms of IoT, we always talk about things, what you use in home appliances. And coming to hardware, basically M2M is mainly connected to the hardware. When it comes to IoT, it is purely an software related, and the data collection for M2M will be on premises, whereas for IoT is in the cloud. And coming to the applications, M2M can be used in on premises data monitoring or remote monitoring, whereas IoT you can take it across the world. You can do it. And when I talk about M2M, still I want to tell you where this M2M is used with respect to the data layers. I think in computer networks, all you would have studied about OSI model, that is Open Systems Interconnection Model. That is, they have described very nicely about 7 layers. You can, now I want to take TCP/IP. Basically 4 layers are there in TCP/IP. You can see in M2M, mainly they communicate between link layer and network layer. When it comes to IoT, they communicate between devices using transport layer and application layer. Okay, all this, I think your students or someone will be using HTTP, MQTT. These are all WebSocketing programming. These are all they will be communicating with this way. And some people they'll be using TCP or UDP. They'll be communicating still in these layers. But when it comes to M2M, they'll be using a link layer and network layer. Either they may use in IP-based network protocols, or they'll be using some kind of Ethernet, Bluetooth. This is where electronics engineers will be mainly working here, and this computer science people will be comfortable working here. Hope this slide will clearly explain what is the M2M and IoT. Now go back to M2M now. Generally for metal cutting industries, M2M, there are only 2 protocols at the moment they're using. One is OPC UA, Open Platform Controller Unified Architecture. The second one is a MT Connect. Okay, what are the requirements of M2M? As I said in the beginning, for Industry 4.0, whatever the requirements are there, similar to that, M2M also has requirements like scalability, mobility, logging, then device gateway failures. It should be very robust, all that it is there. And what are these roles for OPC UA or MT Connect in the manufacturing? The main role is basically you need to make these discrete machines. You should be able to communicate across the smart factory. Like they should start giving the information to the robot so that they can able to take appropriate actions. Then they also should communicate with automated guided vehicles or some measurement systems. Likewise, it should enable the smart manufacturing. These protocols are helping us to connect with cross platforms and enables to make Industry 4.0. What is this MT Connect? MT Connect is basically a data and information exchange. This is a standard again, where you have a CNC machine and then you need to have some kind of adapter. This generally gives by the OEM of that particular CNC machine. And then you are the agent basically, or you can be the agent, or you can take some startup companies. Those people becomes an agent. They will help you to fetch the data and they will try to develop the application what you wanted, like overall equipment efficiency, health monitoring, or factory monitoring, that you can able to develop that applications. Okay, here I want to say only one point. MT Connect will help you to make your CNC machine to provide the information. Now, this is the method where you can able to make the your own applications with this communication. This is one of the M2M communication. The second communication is the OPC protocol. Here, I don't know whether you are able to see my slides properly or not. Here, the earlier what people were doing is you used to buy one device from one vendor A, and you buy a second machine from vendor B, and third equipment is from vendor D. Okay, now you see that the first vendor has given Modbus communication, and the second vendor he has given you HERT driver, and the third vendor he has given in a Profibus. Okay, now the major challenge here is like suppose you want to take this machine's information remotely. What was happening is the automation engineer, or if you are doing, you should have a knowledge on Modbus, you should have knowledge on HERT drivers, you should have knowledge on Profibus. Then, and these drivers also given by the vendors, I mean the suppliers, they always make you to make your life very complicated because they want to control the business. Because of that, people were not comfortable. Here you can see that suppose if you want to take this machine data, vendor A data to thousands of your clients, then the problem here is the loading for this equipment will come. Because you are taking the entire data from this particular hardware, then it is very, very challenging. The loading happens, and he will also say that you can only connect to 5 machines. Beyond that, the electronics gets failed. Due to that, the technology got restricted. People are not able to make use of this machines for complete factory monitoring. But today is not the case. I said you 2005 later, all the machines are capable of giving the data. You need to know how you can able to take it. Thanks to this OPC platform. This is OPC is an open platform control architecture. This is by OPC Foundation. Now, what is the architecture we can see is now vendor A is compliant to OPC, vendor B is also compliant to OPC, vendor D is also compliant to OPC. Now, using OPC, you can able to take your data to OPC server, and with the OPC server. Likewise, you take only to your server. Now you can connect to lakhs of devices. There is nothing is going to happen to this machine, and you can comfortably use it. That kind of flexibility. And coming to the user perspective, like we are like as a CMTA came here to buy the machine. If you can able to give only OPC connection to me, I can make this machine as smart. Now what I want is I wanted only this OPC server from him. Now he accepted for OPC server. I can install my OPC client. I can read all the data from this, and I can make my own applications. Okay, that you can do it. You can see in OPC way, as OPC is basically an industrial interoperability standard. As I think many are mechanical people, you mainly use in shop floor either PLC controllers, or you will be using some IO links, or some CNC machines or CNC controllers you will be using. Now all the industries, all your manufacturing machines which are used in multiple sectors like IT, engineering, industries, process automation, IO level, factory automation, energy, consortia, all these people are accepting this OPC UA. This has become an industry 4.0 protocol, where you can demand whatever you are buying from somebody, see that they are OPC enabled. That has become industrial interoperability standards. Otherwise, earlier people were struggling with multiple protocols, but today with one standard, you can able to get the data very easily. And what are the applications? With this introduction to machine connectivity I have completed, I will be going to machine connectivity applications. What are the applications? Now I said it is mainly for metal cutting. I will limit my presentation also metal cutting. You have a CNC machine. You have a CNC machine. CNC machine will have a CNC controller. It could be a Siemens, Fanuc, or Mitsubishi. Now with the help of OPC or MT Connect. I think for Siemens it is OPC. For others, you have to use different protocol. Now, with the help of machine to machine connect, I mean like OPC, you can get all the informations which are there in the CNC controller. You can able to read it, like alarms, like machine information, then all the configuration parameters which have been used, like what feed, what kind of motor, the current consumption. Then you can also show the alarms, warnings, then your positions where it is and what feed rate, spindle speeds, all that information you can get it from here. But only limitation, even though you are getting the complete machine information, around 5,500 parameters you can able to read from this controller. But the only one limitation what you see is the speed at which it gives the data. As you are taking from machine controller via Ethernet, you will be taking to your server and it comes to the client, and finally you will be representing in your dashboards. If it is a cloud, it has to go to the internet. From there you will be publishing your data in the form of dashboards. But all this process, it takes about 0.5 seconds latency. It means anything you want to take corrective action on this machine, you want to control the machine, you can expect a delay of 0.5 seconds. Any modules which you want, we don't want quick actions. For those you can use M2M connectivity. I mean, you can just request for OPC UA and you can do all the solutions which are going beyond 0.5 seconds. Okay, and there is another problem. Okay, today, if industries, the productivity is very important. For that reason, these machines will be running at very high speeds. Okay, when you are moving at a very high speeds and suppose some accident is going to happen, if you want to stop that accident, then this M2M cannot help you. In such cases, you need to have some high speed controller, and you should have a sensor which should detect the accident, and a high speed controller can immediately gives an emergency stop to the machine so that the accident can be prevented. Okay, this is I wanted to tell you that difference. M2M can be used very nicely for machine monitoring, production monitoring, all that you can do it. When it comes to condition based monitoring, when you want to do accident prevention, you need to use some external sensor and a high speed controller. With that, you can able to beautifully utilize this machine for all your applications. Now I will be showing few applications with M2M, that is machine to machine connectivity. I will be showing. Now, as I said, now with OPC you are getting the data. What I should do with data? The first application is a process monitoring. You can use it for process monitoring. What I am doing is, as I said, you can get 5,500 parameters using this M2M. Now, I am taking only the torque parameters. Okay, if you go to automobile industries, they will be producing the components with the cycle times of 5 seconds or 10 seconds. And these people, they continue production. Okay, till the component fails or till they identify the component is bad, they continue to do the production. In such cases, what happens is you may lead into some rejections. To avoid that, we are showing one solution related to process monitoring. Now I have taken like 10, as I said, cycle time is 10 seconds, and you take 10 components information. With that, my algorithm will be able to calculate the upper and lower threshold. As long as the live data is falling within these two thresholds, you can continue to do production. Okay, that way the operator no need to worry about rejections, and he will be very comfortable. The day this process is going beyond these thresholds, then he will immediately stop and identify what has gone bad. It will give alarm to him. This you can make use of that M2M for process monitoring, and you can also use it for toolware monitoring. If you go to some industries, those people, they always do production, and they simply replace the tool after certain number of components. Like some industries, you can see here, Okay, generally they go like 1,000 components. Let us assume they are changing the tool. Okay, this is one scenario you can see. Suppose with some experience, like I am working in this company for 10 years, and I know that my the for particular process, after 500 components, I have to change the tool. But here the consumable for, I mean the cost for any component is basically the consumables of producing the component. Tool is the basic consumption for metal cutting machines. Suppose if you can effectively utilize this tool wear, or you can, I mean tool life, then you can able to save, and you can able to reduce the cost per component. Now in this case you can see that with experience I am just stopping my tool at 500, but this can go up to even 750. Okay, with the help of one average torque. What happens when tool wear is there, then after some certain value, you can see that the torque experienced by the spindle will be very high, because it is edge is not good, it is blunt. Because of that, the forces, cutting forces will increase, in turn torque increases. That way you can see your torque requirement increases. Okay, you should put a threshold, so that once it crosses to the certain threshold, then you can change your tool wear. The second tool where I mean second tool you take here, after reaching to 750 and even to 1000, the torque is not I mean it did not reach to the threshold. It means 12.5. Still the tool can continue producing another 250 or 500 components till it reaches 17.5 torque. The tool can continue to produce. That way you can enhance the tool life. This kind of provision can happen if you can able to get the data from machines. Okay, this way you can able to tool wear monitor you can do, and you can also enhance your tool life. The third one is, you can, whatever here I explained, these are basically monitoring the process, or you will be monitoring the tool wear. The third one is, you need to control sometime. This is where you can use it, adaptive feed control. What it does is, again for this, today industries they're very particular about productivity. Now here also you put the threshold as your torque. Okay, and you put the limit whenever it crosses the torque beyond 1.2, immediately the feeds has to reduce. That is where you can see now it detected here, it has crossed the threshold. So immediately the override value, that is the feed override, from 130 we brought it to 100. Now you are able to bring the torque information, I mean torque to down. That way you can continue to produce. This is a very good for productivity requirement, because the operator can comfortably knows what is the limitation for that particular process. And if you want to control the tool production, and you set a safety level, suppose if a tool breaks at 5 Newton meter, you put a safety level as 3 Newton meter. Now whenever it touches your cutting forces, in turns leads to torque. These forces, whenever it touches 3 Newton meter, you reduce your overrides, so that you can able to reduce the tool tool protection. You can do it. Here you can see in this case, here that override is at 105, and the torque is keep increasing, and it has crossed at this particular juncture where 3 Newton meter. There immediately our algorithm is automatically reduces the override function to 80%. When you bring the override to 80%, you see that what this torque it is experiencing is very less. That way you can safeguard the tool. By just reducing the feed, you are able to safeguard the tool. Okay, hope these few applications I have explained to you with respect to machine connectivity. Likewise, there are multiple applications. You can, I will be showing some case studies what I have developed using M2M at the end. How to convert these legacy machines to smart. The first one I have finished it. Second lecture is on how to convert these legacy machines to smart. And just check the time, because sir, up to what time I can continue? Hello, anybody is there?
Yes, sir. Yes, sir. Please.
Up Up to what time I
Sir,
can continue?
Sir, you can
you
take
can
up
go up
to
to 11, sir.
10:50, sir. 10:50, 11.
10:50. Another half an hour. I'll be
Yes,
going
sir. Yes, sir.
quickly
Please, sir.
because here any questions are there they can ask because that is the main topic which I wanted to cover.
Yes, sir.
Uh,
I request any participants, if they want to intervene, they can post their queries.
Sir, Reddy, sir.
yes, sir.
I am Dr. Anil Kumar from B&M Institute of Technology.
Yes, sir.
With respect to the machine-to-machine work, can you list out the components of machine-to-machine system, sir? What are the components they are using?
Components, sir.
Yeah.
Sir, actually, machine-to-machine connectivity by default, your CNC controller is a hardware, sir.
Oh, okay. Okay.
Okay. As I told you before, this 2005 before, no, this all these manufacturers they were doing closed business. It
Yeah.
means
Yeah.
they were not worried about interoperability. When you are buying some controller from somebody, they will expect you to buy drives from the same person, and he expects you to buy the motor from the same guy. That way, they were controlling the business. And then all this, and then this, what happened is people are not able to make use of that particular components because when you, as a Maruti factory, you see he buys from thousands of vendors. He will buy the machines and when he wants to make himself very comfortable for automation or industry 4.0, then he is finding very much difficulty to connect all these machines. Then
Okay.
all these developed countries like Germany, US, they sat together and developed a program called as a open modular interoperable standards. Okay, then they said that whoever is the manufacturer, he should go for interoperability. Then only they can give some certificate related to Industry 4.0 complaint. Now it has become very clear. You can buy from vendor A, vendor B, vendor C, and you just take some open standard. Then you can able to do whatever you want in your factory. Okay, now for basically M2M, you asked very specific. CNC controller itself inbuilt is inbuilt with M2M. What we need to request them is enable that license.
Okay, sir.
Okay,
Sir, can we apply this machine-to-machine connectivity technology to healthcare system?
yes, yes. In healthcare also they use machines, right, sir?
Yes, sir.
So wherever you are, see, you can see here, this is related to energy. Those people are also accepting for OPCUA. And then this is some food processing industries like process automation. Those people also they have to give OPCUA so that you can make your own customized solutions for your factory. It is basically already embedded hardware is there for the machines. You need to tell them to give in this format only, OPC UA data format only you wanted. It has become an operability standard. You no need to worry about what kind of interface they are providing. You just worry about only the format, the way data is coming. It is purely enabling the software, sir. There is nothing like hardware we are buying extra. Suppose in some cases like older machines, what happens is you can use some protocol converters. Like their hardware will come into picture. If you have old machines that you want to make into OPC UA, then you have to use some protocol converters and make it as OPC UA. Did I answer your question, sir?
Yes, sir. Thank you, sir.
Yes.
Thank you so much, sir.
Yes,
Thank you, sir.
Sir, I have a question.
Yeah.
From a mechanical engineer's perspective,
Yes.
if I want to upgrade myself and if I want to work in the areas that you are telling now, Industry 4.0 and all these protocols, what is the level of expertise that I should build up, or what is the track for me to explore these areas?
Sir, as a mechanical engineer, at the moment, what you can do is you tell your requirements very specific and make your problem objectives very clear. Okay, what you want to do for a digital transformation, because this is basically a digital transformation.
Yeah.
Suppose you want to get connected to it, like you are going to work with robots, then that's what you want to do. That is very important. Then you can define your problems properly. who can help you, whether electronics engineers or computer science. You connect with them and make finally because this is a easy catching technology. That's why India is very much focusing on it, and we can also improve the productivity and we can focus on new technologies. Okay, yeah, like electronics and all, you don't require huge investments, and thanks to these open platforms today, you with the help of Arduino, so many products are coming out. With the help of this Python programming, you are able to make beautiful solutions at a very low cost. And especially this technology for academic institutes, you should proud and you should make use of the students and make beautiful solutions, and you can make a startup. There are about 30,000 startups in NASCOM, under NASCOM, and all are 1 or 2 students only are making it as a startup. Okay, you continue to do your your teaching, but still you can have an eye on making beautiful solutions by just interconnecting with 3-4 disciplines. Because you are a mechanical engineer, the main asset is with you. Then above it, you take help of some electronics and communication guys to get a connectivity for your machines or your whatever you are working on. And on top of it, to beautify or to represent and do some AI and ML things, you connect with computer science. But again, if you are a mechanical engineer alone also can do it, but you will be spending more time. And yes.
Yeah, okay. Thank you, sir. May I now request Dr. Jagannath Gupta, sir, to please unmute and post his quiet.
Very good morning, sir.
Sir, can you talk a little louder, sir?
Sir, your voice is a bit low.
Hello, am I audible now, sir?
Yes.
Very good morning, sir. So my question is, so what is the effect of this structural health monitoring? How it can be considered in the case of when you come to the consideration of this machine learning or artificial intelligence?
It is a good question, sir. For M2M, as I told you, the limitation. It is very low. I mean, the speed at which the data it comes is very low. But when it comes to structural health monitoring, the data what you gather, generally the bandwidth of your sensor should be high. First of all, something like 10 kilohertz. That means for every 1 second, 10,000 samples you need to read.
Okay, sir.
And then that data you want to analyze. You will not just take the time domain data like vibration versus the time. You will not take it. You need to convert into some frequency domain, and you identify what are how it is behaving. You want to see it. It means the edge. I mean the hardware what you are using also should be capable.
Yes.
Per second. Then and after your analysis, the data also it has to be represented. Okay, that way when it comes to structural health monitoring, we generally, I mean at CMTA what we are doing is we take external like vibration sensor which has a bandwidth of 10 kilohertz, and we take edge analysis. We will not take any help from these IoT layers.
Okay.
We just take only the embedded hardware. There only we do entire analysis there itself.
Okay.
We don't use big data or we don't use any cloud-based analytics because it will not be applicable, because here the speeds at which we are talking is 10 kilohertz. I mean 10 kilo samples per second. Okay, these fellows are basically talking in 0.2, 0.3, 0.5 seconds.
Right.
Yes, got it, sir.
Okay, sir. Thank you, sir. Thank you.
Yes, sir.
Sir, Reddy, sir.
Yes, sir.
Sir, in case of machine-to-machine connectivity, what type of sensor they are using, sir?
Sir, actually the hardware, very good question you asked. Sir, by default CNC machine, if you see, there is a motor as an actuator. Suppose you take a 2-axis turning machine, you have 2 X and Z axis and 1 spindle will be there. For X, you will be having a motor, and the backside you will have an encoder. Likewise for the spindle, you have a spindle motor and a spindle encoder. Okay. Now inside the motor you will have one current sensor, and inside that you will have what is that? I mean thermistor and all that information. Now by default your CNC machine has inbuilt sensors and actuators. and that information is going to the CNC controller. Now, with the help of this machine to machine connectivity, you are taking the information. You are not investing anything on hardware, sir.
Okay.
Already it is there. Already machine is built with sensors and actuators. And when you say that M2M is enabled in your machine, it shows that already the CNC controller is taking those information from sensors and actuators. You are in turn taking it to your computer.
Yeah.
Yes.
Thank you, sir. Thank you.
Thank you. Should I proceed, sir? I think we are running out of time.
Yes, sir. Yes, sir. Yes, sir. You can just brief us about that topic, sir.
Yeah, I just quickly go because
Yes,
I have a lot of information to share on AML because mechanical engineers know.
Yes, sir.
That's always what we can do with these latest technologies.
Yes, you can just introduce. Yes.
At the end, we will again ask questions, sir, if time permits. Yeah, these are legacy machines. Legacy machines, I told you, in India, 70% of the machines are legacy machines, which are, when I say legacy machines, they are 20 to 30 years old. And why they continue to use it is because they are doing the job what they're supposed to do it. But today we are talking about the factory floor monitoring, machine monitoring, and then digitization. These people are becoming a backbone. I mean, even though they are the backbone, but they are becoming hurdle to give the real-time information or real-time visibility of their activity. Why people are not switching over from legacy machines is one is you have to invest a lot, and there is a fear always when you buy a new machine. You don't know whether they serve the purpose or not, and always there is some kind of difficulty will be there. Many times they use a different programming languages for legacy machines. For the latest machines, you need to equip with the latest programming skills. That is also one difficulty. What are the common characteristics of legacy machines? You can see there are outdated technologies, and even though you want to buy a new such machines, it may be unavailable to purchase. And of course, even though you have a company existing, but they will not be providing a support and maintenance for that particular machine. This we call it as legacy machines. And what is I mean, why we need to focus on this legacy machine is, as I told you, in India, most of the factory floors, they have machines which are 20 or 30 years machines. And these people, when you talk about Industry 4.0, they always tell that they want to make into modern factory, but they have a legacy machines. In fact, if you go to Indian Army workshop, they have 60 years old machines. Okay, but they want to make their machines into smart. Okay. Now, if you can able to if you can able to address the solution, then they will be very happy. These people, and also you can save the cost of 70%. You can in turn save the capital cost. And okay, we can again I can say that even though it is a challenge, but we have to thank this speed of developments happening in electronics and even software programming. The cost of the sensors and then cost of the edge devices, embedded boards I'm talking about, there are in 1,000 below prices you are getting it. Because of this, you can make these legacy machines into smart. How to make that? There are only 4 techniques. One is a smart sensors. You can, if you want only some information from the machine, like machine status, productivity monitoring, just by mounting one current sensor, you can able to make your machine into smart. And if you are very particular, like as I said, M2M kind of connectivity, then you have to change the complete motor, drive, and controller. And if you feel that you just want, you have a machine which is capable of giving some information that is sufficient for you, then you use some edge gateways. They can convert from one protocol to other protocol and make your legacy machines into smart. And if your requirement is just for monitoring, then you add some video cameras so that you can make your machine into smart. And what are the best practices generally people are using for legacy machines is you can take the data from PLC, you can take data from your storage devices, or you can mount some external sensors, or use some edge gateways like connectivity things, where if your machine is having RS-232, you connect with the RS-232 and read the data. And this is one example you can see in Fanuc machines, which are old machines. If you have in your workshop in mechanical engineering, you just if it has RS-232, you just buy this converter. This is a multi-port converter where it will take the serial input and it will give you Ethernet. Now Ethernet, you can take it to your server and read the data of your machine. This may be costing about 7 to 12,000 rupees. You can make your old machine into smart. And then suppose many times people wanted to connect to two machines. You can see this machine has IO link, and you can use some protocol gateway. And I mean, this is, I think, PLC. Now that PLC has this. I mean, this is from one vendor A and this is vendor B. For this, PLC is giving you directly Ethernet protocol. This PLC is also giving Ethernet protocol, but the machine, you have some temperature sensors, and the temperature meter is giving in serial bus, and finally this serial bus you are connecting it to this PLC, and here some protocol conversion will happen, because this is taking RS-232 information. From there it is converting into Ethernet. Then directly you can use these devices to connect to your main server. And there are, as I told you, external sensors you can mount, and you can use it whatever your requirement. Somebody said the structural monitoring, you mount vibration sensor, or you can mount some acoustic sensor. You can do your structural health monitoring. And if your requirement is the thermal behavior of your machine, then mount the temperature sensors externally, and you take it to your dashboard. And there are edge gateways available where you can able to convert from one protocol to other protocol. This is in CMTI we have taken one legacy machine where we just demonstrated. It is not any commercial aspects. We want to show how to make this legacy machine into smart, and what kind of modules you can able to incorporate to a legacy machine. I mounted 6 temperature sensors, that is PT100, and we also mounted current sensors that you can see. And for health monitoring of the spindle, I mounted accelerometers. And then for utilities monitoring, I added some pressure sensors, and it will give, if it is a pressure switch, it gives digital output. If it is you want to monitor the pressure, then analog, it will give 0 to 10 volts. And we also developed one computer vision based solution where you can able to find the quality of your product. Okay, I will be showing small demonstration. These are the sensors. You can put whatever you want, you can put it and take it to your, you need to connect to your data acquisition system where the data is going. And I have one, this is the edge controller where it will read the data from your DAC system, and this data will go to the cloud directly. From cloud, I am taking it to a remote location and developing a dashboard. This also I don't know whether I can show here now. You are able to see my screen, sir?
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Yeah, these are some solutions. I'm just showing the legacy machine. Yeah, I think, yeah. You can see here, no, sir. This is a legacy machine. I have made it into 4 modules where thermal behavior of the machine and spindle health monitoring, then energy monitoring, then part quality check also. You can see here in part quality. In part quality, we are making 2 holes, and then it is measuring the diameter of each hole. You can see the diameter 1 and diameter 2, and if the tolerance is meeting, it will. If it is both the diameters are within the tolerance and the pitch is okay, then we say that the part is fine. Then it will show it as pass. If it is not falling within the tolerance limits, then the part will be failed. Okay, that is what we made one solution. And for temperature monitoring, you can we have mounted 6 temperature sensors across the machine, like the spindle motor temperature, ambient temperature, like this. And then based on this thermal behavior, we also seen in a CNC machine how much it is drifting. Using A and ML technique, we could able to find out how much deformation is happening because of this temperature. You can see 8.2, 3.1 and 8.94. Yeah. And then coming to health monitoring, there was a question from participants. You can see I just mounted one accelerometer. With accelerometer, I'm deriving all these faults. You can what is the speed at which it is running? What is the it is a triaxial accelerometer. All three directions. What is the vibration amplitude? And it also shows the unbalanced faults, looseness fault, misalignment, then structural resonance, tool wear, then abnormal process parameters. All these things it can able to detect with a simple vibration sensor. And for energy monitor, those who are whenever some students they want to do different materials to cut during that time, they can monitor just the current information or power information. They can able to link to their process for material to material how the power is or torque requirements are changing. This is a simple 500 rupees sensor. With that you can able to get all this information. With this I have finished the legacy machine conversion to smart. You see that just by mounting these sensors, I am able to do all the required information which is required for the machine. Hope it is clear. Now I'll be getting into IoT based vibration measurement. I think some person was asking about structural. This he can see. With vibration sensor, basically you can measure frequency. I mean, for vibration, you use the frequency, displacement, velocity, and acceleration information. And this is one plot where you can see in when you look at frequency versus amplitude. Generally, you should use the displacement unit for low frequency applications, and velocity you should use between 10 to 1000 hertz, and you should use acceleration above 1000 hertz units. Now I will be showing and then when to use what. You can see that for bearing damage and all, generally people use acceleration units, and for velocity they use it for imbalance misalignment, and for displacement basically ground vibration people use it. And then fundamentally when you take your FFT plot in different units, the signal is same for all the, I mean we are taking from one vibration sensor, time domain data is same. Now but when you convert into units of acceleration, you can see that you are able to pick more frequencies. When you take the unit as velocity, you are able to get few peaks only. But when you take the same information in displacement unit, you get low frequency information. Very beautifully it is showing. Okay, with this we can say that even though the data is same, the time domain data is same, when you convert into frequency domain with the different units, you can able to get different signatures. Okay, acceleration is widely used when you want high speed data, I mean high bandwidth information. With that you can able to find out so many faults of your process. And then how to choose the right accelerometer. You need to know what is your requirement, what is the range you are looking at, and then the sensitivity of the accelerometer plays an important role. And then whether you want single axis or 2 axis or 3 axis. Generally 2 single axis and tri-axis you will get it. And then weight of the accelerometer is also one of the important. I think this for structural requirements, the weight is very important criteria. Otherwise your weight of your sensor will in turn contribute different results. And then mounting options. Generally 5% of your this one structure you should not cross it. Ideally practical applications not even 1%. And then suppose this is my requirement. I mean when you are looking at mounting options, you also should take care of it. Handheld sensor generally up to 500 hertz only you can do the measurement. When you use magnetic stuffs, you can able to do measurement up to 2000 hertz. But when you use adhesive, you can only do 2500 to 5000, because there also the friction will create the heat in turns your adhesive will spoil. Then you need to use some stub. You should screw it with a stub so that you can able to do measurements beyond 6000 hertz. I mean 6 kilohertz. Whoever is looking at 10 kilohertz, this one, you need to mount your sensor with the help of stub. Then you can get very results. Okay, now for machine tool, generally 10 kilohertz is widely used, and the range they use plus or minus 50 G, and the sensitivity is 100 millivolts per G. Now when you are going to some websites, then you can Once you know your requirements very clearly like this, you can directly get into the websites and you can clearly see those and then buy it. And as the requirement is for academics, you can have a look at it. Generally, people what in academic institutes they follow is you have a machine and you mount the vibration accelerometer and you buy the DAC system and do some FFT using MATLAB or LabVIEW and do the vibration measurement. This is a general practice. But here the basic limitation I'll tell you, the cost of the accelerometer is high because these are all industry standards, and these DAC acquisition systems also very expensive. And then even this LabVIEW and MATLAB is also not free programming softwares. And to just do one measurement, you need to have this sophisticated infrastructure. Then only you can able to do right analysis of your motors, rotors, or spindles. But today academic institutes, what they're doing, they are buying low-cost ICs like this, analog devices. You buy an accelerometer, and you can use some. You can from Texas Instruments. You will get a bare. I mean, you can get ICs, bare ICs. You can get, and you can take one bare PCB, and you can mount whatever way you want. And you buy one Wi-Fi IC, and I mean, this you will get it for 320 rupees, something like that. ESP. Now using this MEMS accelerometer and this Texas microcontroller, and you can use some transmitting data for Wi-Fi ICs you can use, and cloud storage also there. I mean, nowadays it is very cheap cloud storages, and you can make your user dashboards. The entire solution, this solution you need to invest in lakhs. The same thing, if you can make a package solution like this, you can make in thousands. Okay, these accelerometers you are getting it for 3,000 to 12,000, and microcontroller you can get it for 7,000, and then wireless 300 rupees, and cloud storage maybe 1,500 per year. And you can make user dashboards with open source softwares. You can make user dashboards. And when you are doing that, as I told you, for vibration measurement, the criticality is programming inside your embedded board. There you should have VHDL coding you should know, or hardware programming, C++. You should know. Then you can able to write programming inside the hardware. Then entire edge computing can take place inside this IC itself. Then and today IoT people are using widely for condition monitoring for these reasons. One is for cloud storage, because if you take remote locations where you want to collect a lot of data, you need to have GBs of hardware. Hard disks are required. To avoid that, every time replacement of hard disks, people are going for IoT. With less cost, you can able to store billions of data, and then machine learning you can implement with IoT data, and you can use it for predictive maintenance, and remote monitoring can be done. Now the last topic of my presentation is smart machines and smart machining. This is the machine we have developed in 2013. You can see that that time itself we worked on this smart modules. One is intelligent machine error compensation, how to correct in real time positions, geometrical errors, and thermoelastic corrections. It is in real time with simple temperature sensors, but we have done extensive experimentations, and then with the help of AI and ML modules we could able to correct it very effectively. And to work on such modules you require an open architecture motion controller. We bought a motion controller which can able to integrate the algorithms or modules which we developed by us. And then for health monitoring we worked on a spindle health monitoring, on machine balancing module, then sensor fault detection, because for this intelligent one, when we talk about intelligence, basically we are depending on sensors. If the sensor is faulty, the entire module itself becomes a faulty and machine behaves erratically. For that reason, we also developed a sensor fault detection, whether the data what it is coming from the sensors, is it okay or not. Then we worked on tool condition monitoring. Then we also worked on remote monitoring and control for intelligent prognostics, like surface roughness prediction. That also we have worked to some extent, not to completely, because Now this is a thermal error. I think if you look at machining errors, I think everybody may be knowing about how difficulty to achieve 5 micron repeatability on a job. In I think especially in a production environments, they'll be always worried about why it is not repeating. The basic problem is the thermal. 60 to 70% of your machining errors come from thermal. If you can able to address this, you can able to repeat your component accuracies very nicely. I mean geometrical errors. How we have done, I will show you how we developed this thermal error compensation module. This is a we have mounted 6 temperature sensors. Here you can see 1, 2, 3. We have mounted an X slide, Z slide, and we also mounted on the tool, and then we have mounted on the spindle likewise, and then ambient air conditions likewise 6 sensors we have mounted. Initially we have mounted 25, we brought it down to 6. Then after doing the thermal error studies, you need to just by getting the temperature data is not sufficient. We also need to measure the displacement relationship between temperature and then displacement we need to arrive. For that we mounted capacitive sensors. Now by different loading conditions we can able to get the mapping of temperature versus the deformation. Now we have given that huge set of data, almost some 30 or 40 days data we have given to neural network model. It is done in MATLAB. There you can, the neural network will take inputs as temperature, the outputs as X and Z deformation values, and then in real time when you want to compute it, we wrote a C program, and finally the C program will give the outputs like this. It is taking the inputs as only temperature, and my neural network model is computing the deformations based on the data I have given for teaching, and finally you can see the results. Initially I used to get 50 micron. After incorporating this neural network model, we could able to brought it out to 3 microns. You can, for some applications where linear relationship is there, you can use regression techniques also. And when I say that experimentations, what you need to do it, basically you can see for spindle thermal behavior, there is a standard ISO 233. Using that standard, I found out what is the spindle effect due to environment, what is the spindle or machine effect on a spindle running, and what is the effect from the axis movements. All that I studied. Three different tests at various temperatures we have studied, and for thermal deformation we have used capacitive sensors. With that we can able to get the displacement values. In real time what will happen, I don't want this capacitive sensors. I'll be using the low cost temperature sensors on a machine, and my neural network model will directly give the displacement values. And this is how it has been implemented. I don't have time. And finally we have also validated on a spherical component where the requirement is radius should be within 1 micron. I think it is wrong. It is the radius has to be 1 micron, tolerance is there, and form also 1.2 micron. We could able to make almost 50 components, and we have checked that my error is not crossing beyond 1 micron. Earlier what was happening, for every 5 components I used to take it to CMM and correct my tool offsets. But later, without any measurement system, we continued producing 50 components, and we validated our algorithm like this. And we also developed one optical tool set station with the help of a vision-based system where you can measure the tool wear, tool radius. We can do it. Here also you need to use some kind of algorithms for measuring the tool wear. And then for positioning error compensation, we have used a neural network model. Actually time is not there. I just show you something, but not. I may not be very successful in completing it. And then for health monitoring, we have put a vibration sensor, and with the help of LabVIEW, we have used this frequency spectrums, and we can able to detect the faults. And for online machine balancing, this is the work we did long ago, and you can see that here also one vibration sensor and either encoder or tachoprobe, you can able to do your balancing of your spindle very effectively at the machine level itself. Generally people they do offline these measurements, but if your requirement is for any rotor you want to do balancing, one tachoprobe and one vibration sensor can help you to do these modules, because the softwares and all you'll be having inside the campus, you can manage with that. And this is the vibration monitoring. How, as I said, what is required. You have a spindle, you mount the accelerometer, and you mount the tacho probe. With the help of FFT, you can able to do balancing. Initially, we have done in MATLAB. Later, it has been done in LabVIEW. And for prediction of surface finish, you can see that what and all we have taken as the inputs. Generally, roughness, I see a lot of papers from mechanical faculties. Only they use cutting parameters, feed the depth of cut and spindle speeds. But actually, you need to consider the vibration of your tools, X, Y, and Z, and also acoustic sensors. With that, you can able to build the nice models, and then you can also validate with your FEM models, and then that becomes a very effective experimentation, and you can also very rightly link with your surface finish. And as I told you, we also worked on sensor failure detection, where we need to know whether the data what it comes from the sensors is correct or not. And just to summarize, what are the techniques, the AML techniques or any other techniques we used for building these modules, intelligent modules? For positioning error compensation module, we used neural networks. With the help of MATLAB and the C programming, we could able to implement this solution in real time. And again, for thermal error compensation module, with the help of regression techniques and the neural networks, and for regression, we used Minitab. Neural networks, we used MATLAB NN toolbox. And you can, if you know a little bit about C programming, you can able to interface to your CNC controller so that you can able to take real-time corrections. And then for health monitoring of spindle, you should know a little bit about digital signal processing, and you can use LabVIEW or with data acquisition, hardware and sensors, you can make use of data health monitoring. And the online balancing module, you should know a little bit about order analysis techniques. Then you can do in MATLAB or LabVIEW. All these techniques are available inside. I mean, the tools are available. You should know the techniques so that you can able to make use of those techniques using these tools. And if you know, if you have this data acquisition, hardware and vibration sensor, you can do online balancing also. Then for sensor fault detection, we have used a technique called as a principal component analysis. And these are the tools we have used it. And for all this, expertise, what we did is we could able to interface to our machine and make as an intelligent machine with the help of C, C++, LabVIEW and Aero Basic programming. And if you want to make such kind of IA and ML, I just want to show you the facility is also very important for you to do experimentations. First of all, you should have machines, and you should have measurement systems to check it up whether the machining is going on well. And you should have sensors like capacitive sensors, accelerometers. Then for force measurements, you need to have dynamometers. Then for instruments, you should at least have a spindle error analyzer. Sorry, you should have spectrum analyzers, and or you should have LabVIEW or MATLAB with a data acquisition system. And if you have some multidisciplinary expertise, you can make beautiful models. Like if you have a person with MATLAB, LabVIEW, Python, C++, then with the skilled manpower, you can make these modules very easily. With this, thank you so much. Sorry, I could not able to present well for the smart machines and machining, but I wanted to show you because there is a lot of scope where academic institutes can guide students and make students to work on these modules. We can because I came to one OEM here in Mac Power CNC. These people are busy in making their machines, rather than they never work on the technologies. Only academic institutes and students only can work on these high-end technologies and able to educate and make our students to send to this kind of manufacturing companies, and they can apply more value to that companies. Otherwise, they will be doing the routine job, and then whatever we are talking about, Atmanirbhar Bharat, all that may not be possible without academic support and students support. Thank you, sir.
Thank you very much, sir. If any participant has any queries, you can please use the option to raise the hand. I will unmute your speaker. You can just pose your question. Sir, I have a query regarding the temperature and thermal monitoring that you showed. Is only temperature profile sufficient to monitor the precision of the manufacturing processes?
Sir, is it a process or see, basically the component at the end, what you are getting, right?
Yeah.
The component. Basically, what we see, one is the dimensional tolerance. Suppose if you make a diameter of 200 mm,
Yeah.
basically you will get 199 point something or 200 point something you'll get it. That error for what reason it is coming? Because the machine basically it is built with slides and there will be some external vibrations. Because of that, machine is prone to induce some errors. But these errors has to be minimized. Okay, then only you can able to achieve the accuracies what customer wanted. Customer always want 200 only, but we cannot replicate 200. We can get something, but this error again, that error we have to bring it as close as possible. Some people may give for 50 micron, some people may give 20 micron, some people may give 5 micron, some people are giving 1 micron. But the machine, what that ultra precision turning machine, I mean the machine, what I'm mentioning here, this machine can produce the error. When I make a component of 200, it will give plus or minus 0.1 micron. Can you imagine? We can make a 0.1 micron geometrical, because this works on aerostatic slides, or we also developed hydrostatic slides, that machine USCPTM, where there is no friction at all, and then it can able to move in 1 nanometer, and then the accuracy of the entire slide is 0.5 micron. And when I make a component, if a diameter of 50, I can able to confidently give 0.1 micron error. Yes, error. But I mean machining accuracy, in component accuracy, in fact, in production environments, I mean these machines, they are not widely used because these are very expensive, 5 crores each value is. They cannot afford this. They use a very low cost machines like 10 lakhs, 15 lakhs, 20 lakhs. Turning machines I'm talking about. There generally they claim 5 micron or 10 micron. But such machines also you want to give value addition. Then if you can rightly map these thermal errors, then you can improve the component accuracies. Yes, that how we have explained to you, sir.
Yeah. Sir, then with regarding to that conversion of legacy machines to smart machines using some sensor integration, as per your experience, to what extent can you match it with the modern machines? Is there any limitation to what we can do?
Yeah, there is a limitation because you will not get all 5,500 parameters. I told you, with machine to machine connectivity, you get 5,500 parameters.
Yes.
You have to get compromised, and you can. What is very critical for you that you need to identify whether you want a machine status, or whether you want machine productivity information, or you want to process information. Based on that very particular sensors we can mount, and we can take only to that extent information. But it will serve the purpose. By default, why legacy machines are still using, because they are doing their duty properly, and it is helping for you to progress. That's why you are continue to use that legacy machines. On top of it, anything you want, the information, you add some sensors and take the real-time visibility of that particular machine and do it. We don't need a complete information from that machine, but if you want only for maintenance engineer, he is very particular about that machine. You
some typical data.
Vibration sensor and do analytics, and with the help of if you want A and ML to be used there, you can use the RUL, remaining useful life models, with the help of A and ML, and you can help to maintenance engineer.
Okay, sir.
Yes.
Okay, thank you very much, sir. Anybody? I think yes, we can conclude the session, sir. And on behalf of the organizers, I thank you, sir, for a very interesting, and you have presented a wide range of developments in smart manufacturing and how machine to machine connectivity and integration can be done. Even you have touched upon concepts like conversion of legacy machines also. and even monitoring, structural health monitoring, etc. Thank you very much for a very informative session, sir.
Thank you, sir. Yeah. Actually, I could not show some. I could not show my some more modules with the machine-to-machine connectivity. I missed it. Process monitoring.
Yes, yes, sir. We expect you to be associated with the department and the institute, sir. We will again arrange for a session dedicated to manufacturing so that you can present further information about this, sir.
Yes, sir. Thank you so much for giving this opportunity.
Yes, sir. Thank you very much, sir. Again, thank you very much. Participants, we will be ending this session now. We will rejoin after a break of 30 minutes. We will let you know the time in the WhatsApp group. Please join for the next session also. Thank you very much.